Okay, for this open book quiz, all of the marks are the following. For knowledge, the marks are out of 9. For application, the marks are out of 11. And for communication, I'm just giving you a mark out of 5. Alright, let's begin. To begin with every one of these graphs, for the first graph, you'll always go and tell me what the amplitude is. A in this case is 3. You'll also need to tell me the period. The period is equal to, well, it's 360 divided by 0.5, which is 720. Next, we need to identify the phase shift. How much it moves left and right. There is none. There is no phase shift for this graph based on this 0.5x. There's no bracket of x minus something in there. That's why there's no phase shift. And then finally, we have to look at the vertical shift, which is identified by this -2. The -2 tells us that we move down. For a vertical shift, we're moving down 2. When we draw this graph, we need to draw 3 graphs. We're going to start by creating the 3 graphs. The first graph is going to be y is equal to cosine of x. It's going to be in black. So cosine starts above the line at 1. And its period we've identified to be 360 just for the first one. Always starts off at 360. So there we go. We're going to go to there. Plot our point. So we start there and we end. We start at 1 and end at 1. You know that for each one of these graphs, we have 4 different parts for the original graph. So we know that if it starts and ends at 1, that means exactly halfway we have our minimum occurring at -1. And then halfway between these 2 graphs, we know we have to cross the x-axis. And in this case, half of 180 is 90. So that's where our next point is. And then we have 270. And then we simply graph our curve. Alright. Our next curve will be showing the stretch, the vertical stretch. So we'll write y is equal to 3 cosine of x. In order to graph that, we're just going to show our amplitude is 3. So it starts at 3, it hits 0, and it goes down to -3. And then it goes back up to 0 again, and then it goes up to +3. Drawing the curve, we have this. One last try. Now, after this, our next graph will be y is equal to 3 cosine of 0.5x. So the 0.5x represents the horizontal stretch to 720. So now, from our graph, you notice from our new graph of 3 cos x, we have all the points. So now we can start by graphing it again. So we know that it's going from 0 to 720. So we know that our first point starts at 3. Our last point will also start at 3. Our middle point is exactly halfway between 720, which ends up being 360. And we know that it's going to go down to this position here. Now, halfway between 360 and 720 is 540. So I'll put my next point right here. And then similarly, we'll do the same for our other crossing point. And now we take a moment and we draw our new parabola. Not parabola. Cosine curve. And finally, we draw our final graph, which is going to be green. So our final graph is y is equal to 3 cosine of 0.5x minus 2. So this is what shifts down our graph by 2 points. So all we have to do is take all of the points that are on the blue line and move it down exactly 2 units. So this point here, so at 0, so this point here is now shifted down to here. This point here is now shifted down here. This point here is now shifted here. This point is shifted here. This point is shifted here. And there we have our final curve. I'll show you basically where all the marks are. All k values will be drawn in yellow. All a values will be drawn in purple. And there we have our marks. Notice the last marks for A come by actually just moving our graph down by 1 in the end and stretching it by 720. Let's continue on with question number 2. Just like before, we need to identify the amplitude, the period, the phase shift, the vertical shift, and this one has a completely one extra step, which means we have to actually flip it because of this minus sign that we have right here. The -2 tells us that eventually we're going to have to flip our graph upside down. We'll start by drawing our basic graph for this equation, and notice it's sine. So what we will do is we'll take sine and we'll draw its basic graph. And remember that that sine with no change goes from 0 to 360. So that's what we're using for our graph in this case. So first point is at 0, 0 for sine. It starts at the halfway mark, the vertical shift. Its end point is also going to be 360. Now, in between, sine crosses the x-axis again, and then exactly halfway between 180 and 90 is where its maximum occurs. So we'll quickly draw that point there, and our minimum point is going to be drawn at 270 and -1. And there we have y is equal to sine of x for our base graph. The next thing that we have to do is we're going to have to make sure that we identify all the key ideas. The amplitude, the amp or A value is going to be 2. There, the period, well, is just 360 divided by, if you take a look here, there's no value in front of this bracket here. So that means it's 360 divided by 1, which is our B value, which is just 360. There is a phase shift. Now, remember, it's opposite world because it's plus 90. It really means it's moving to the left 90 degrees. Minus 90. Or you could write down, like what I tend to do with most kids, that I tend to remind them that they can write left 90 degrees. Last but not least, we have to figure out our phase shift, our vertical shift. And when we have our vertical shift, in this case, it's +2, so that's really mean up to. Or it's another thing. We could add +2 or something. So this is another way that I've seen you guys do this, so that's all right. All of these are great. Now, here's the next thing. We're going to go and draw our next graph, and I'm going to explain how it goes. So based on our amplitude, our phase shift is our period is 360, and our phase shift is left 90. So now what we're going to do is we're going to draw our second graph. That's going to be in red, and it's going to be y is equal to 2 sine of x. Now the 2 sine of x is going to actually take our points that we have here, 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 and here, and it's going to stretch our graph vertically. So now we have, instead of 0, we still have 0 for our first point on our graph. And for each one of these key points of 0 where it starts at 0, 2 times 0 is still 0, so guess what? They're still going to be on that key, on the basic points. So all of these 3 points will be 0. Now, the only points that change are going to be this point here and this point here. So 2 times 1 gives us 2. So we'll just move that point up, and 2 times -1 gives us -1. So we just move it down to this point here. And finally, we just have to do our graph. Now, you've noticed that we've stretched the graph vertically. Now, what I tend to do next is I take a look at if we have to stretch the graph horizontally. And based on our graph, our original graph was 360, and our new graph is still 360, so there is no horizontal stretch. The next key thing that we have to do after the stretch is to take a look at the points that we have in these basic graphs and determine as to whether we still have a flip. Now, we identified that we did have a flip. The -2 that we had at the very beginning told us all the points are flipped upside down. And what we're going to do is we're going to take a moment and we're going to make sure that these points are graphed. I'm going to graph these points in a nice, interesting little green value. Okay, so we take a look at our last graph. We're going to call it y is equal to -2 sine of x. Now what that means is for the point 0, it doesn't change. For the point positive 2 that we have on the red here, we're going to go down to negative 2 instead. We have a 0 here, and then we go down. Now if this is negative 2 and we flipped it, it's now positive 2. And then now we have a 0 still. And then finally we graph our sine curve, but upside down. And there we have our graph. Now, we've identified the basic graph, the vertical stretch. There's no horizontal stretch. There is a flip by changing the 2 to a negative 2. And then next, we have to go and take a look at our moving left, right, and up and down. Our left and right is going to be identified by our phase shift. And we're saying that we're moving everything to the right, nope, to the left, 90. So what I'm going to do is I'm going to draw that in a healthy purple. So in order to show what our phase shift is, we're going to keep everything else the same in our equation, but we're going to change x to x. Now because it's left, we're going to go plus 90. So it becomes x plus 90. So all we're going to do is take each one of the points that are on the green graph, and all we're going to do is move them to the left 90 degrees. So as you can see, from 0 we go back 90, and from this point here going back left 90 is going to break us from 90 to 0. This one goes from 180 back to 90. This one goes from 270 back to 180, and then this one, 270 back to 180, and then this point here goes back to 270, and then what we have to do is finally graph it. And there we have it. And so our last portion of our graph is dealing with our vertical shift. Now notice it's plus 2, so we're moving all of the purple points up 2 graphs. We're going to draw this in blue. So basically this point goes up here, this point goes up here, this point moves up here to this point here, moves up to here, and this point moves up to here. So we'll actually graph each of those points really quickly. So here we go. First point, second point, third point, up 2 for this point here, and up 2 for this point here. And our equation is y is equal to negative 2 sine of x plus 90 plus 2. So when we graph, we have something that looks like this. Now, as before, I'll show you where your marks are. So before I gave you 2 marks for the k values of figuring out the period, the amplitude, and the phase shift, but 1 extra mark. One of the marks is now being awarded to identifying that there's a flip at some point. Now they just have to show me evidence of it, whether you flip the graph or whatever. Your next set of points, your next set of marks is out of 4. It's out of 4K. Now, basically, you're getting a point for the stretch, a point for flipping it, a point for graphing the phase shift, and a point for graphing the up and down. And that's it. For this last graph, we have to identify all the key ideas again. So for this graph, basically you'll notice our amplitude is 0.5. Our B value is 2, so we have to figure out what that period is going to change to. And in this case we have minus 135 and 1.5. So we have the following answers for each point. Our amplitude A is going to be 0.5. Our period P is going to be 360, and we take that 2 value and divide by 2, which is 180 degrees. Sorry, 180 for its period. The phase shift, that is minus 135. Remember, think it's opposite world. So instead of going, so it's basically moving to the right 135 degrees. Right? 135. And then our final value here represents our vertical shift. And our vertical shift in this case is up 2. No, up 1.5. 1.5. So now, just like before, we're always going to write out our equations. So what we'll do right now is we'll make sure that we start with our basic graph, and as usual I'll always start in black for that one. So this is sine, so sine starts at 0. It ends at 0. Its middle point is also at 0, so that's at 180. Its maximum occurs at 1. Its minimum occurs at -1, and it's at 270. So now what we're going to do is we're going to write y is equal to sine of x for our base graph and graph it. And there we have our graph. Now, the next thing we have to do is we have to write up our next equation. And our next equation is going to identify the vertical stretch, which is 0.5 sine x. So 0.5 sine x means its amplitude, all the points have been squashed to a half. So 0 times 0.5 is that. So 1 times 0.5 gives us 0.5. This is at 0, and this point here is at -1, and this point is still at 0. So now what we have to do is graph our sine curve. So the next graph we're going to draw is we're going to draw this nice green one. And the equation for this graph is 0.5 sine of 2x. Now remember, we calculated our new period to be exactly 1/2. So we're going to look at all the key points for this graph here. Y equals sine of x. And we're going to cut down all of the x values by exactly 1/2. So half of 90 going this way is going to be, half of 90 going back is going to be 45. Another way of doing this would be, okay, I know what my period is. I could cut all the distances in half, or I could look at what the new period's supposed to be. It's from 0 to 180. Now, here's what you do. You know that the amplitude is still 0. So what you do is you know that it's at 0 and 1. It's at 0 at 180 and 180, but it's also 0 exactly halfway. And we know that its maximum, it doesn't occur at 1, it occurs at 0.5. And then we do the same again. Now, remember what you could have done. I also said you could take all the x values and chop them in half. 180 divided by 2 goes here. 270 divided by 2 goes here to 135. 360 divided by 2 goes to 180. And then what you do is just quickly draw your graph. Now, just make sure your 2x is in brackets. Try to remember that. Sometimes you forget. So our next graph, I'm going to draw in this handy-dandy purple. The next portion of the graph represents the phase shift. Y is equal to 0.5 sine of 2 bracket x minus 135. So x minus 135. We look at that. that tells us our phase shift is right 135 degrees. So each of the points that are on this green graph are moved 135 degrees to the right. So this point here, our 0, moves all the way over here. And all I'm going to do is transpose, move every one of those points exactly 135 degrees to the right. The easiest way of doing that is start with the last point, put our point down. Our new point is at 135, so I'm going to write that in. And then we look at our last point, which is also at 180, and we're going to move it to the right 135. So, or we can add 135 plus 80 to get the next number. So basically, I'm just going to move my graph exactly to 315, which is right here. So our last point on our graph is going to be 315 if you wanted to draw it that way. Then what we have to do is we have to remember that exactly halfway between 225 is also at 0. Its maximum is going to be at 0.5. Its minimum is going to be at negative 0.5. And then we graph our trig function. And there you have our graph. The last thing we have to do is we have to show what our vertical shift is. And our final graph I'm going to do in blue. And we're going to have the following. Y is equal to (0.5) sine of 2x minus 135 plus 0.5. And all that means is we're going to take each one of these points on the purple graph and move them up exactly 1.5 units up. So 0 goes to 1.5, this point goes up to 1.5, and the same for all of these other ones. And I'll show you what the final graph is, and then I'll tell you what the final marks are supposed to be. And there we have our final graph. All points translated up, exactly 0.5, 1.5. 3 marks are awarded for identifying all of these values for our translation and phase shifts and vertical shifts and stretching of the period. Finally, all your marks for application are going to be just being able to draw each one of the graphs properly. Okay.